So welcome to the final lecture for General Chemistry 2 of 2 in the spring of 2020. What we have left to do is simply to go over the final exam we've had. So to go quickly over the second exam, 235 Celsius is a lower temperature than 445 Fahrenheit. 235 Celsius is 255 Fahrenheit, so that's false. All atoms consist of a nucleus containing protons and neutrons surrounded by one or more moving electrons. No, hydrogen 1 doesn't have any neutrons, well, not all atoms have neutrons. At the same temperature and pressure, 10-liter balloon of helium contains the same number of atoms as a 10-liter balloon of neon. That's Avogadro's principle. At the same temperature and pressure, equal volumes contain equal numbers of particles. Photons of red and blue light have the same frequency in a vacuum. No, they have different frequencies. That's why they're different colors of light. And finally, a chlorine atom is smaller than a chloride ion. Yes, you make a chloride ion by adding an electron to the chlorine atom. That makes it an anion, and it makes the whole thing larger. Problem number 2. What is the volume of a balloon full of nitrogen at 75 degrees Celsius if it had a volume of 24 liters when the temperature was 25 Celsius? Well, that's of course Charles' law. Volume divided by temperature equals volume divided by temperature. And of course, since it's a gas law, you have to use absolute temperature. So the original temperature was 298 Kelvin. The final temperature was 348 Kelvin. So 24 liters times 298 divided by 348. And the volume of the gas should now be 28.0 liters. Problem number 3. Indicate the shape of each of the following molecules held together with single bonds. Well, silicon tetrachloride has 4 bonds. Silicon starts with 4. The chlorines each put in 1. We end up with 4 bonds. 4 pairs of electrons around the central atom go into a tetrahedron, and so that's the shape we see. Number 2, selenium dichloride. Selenium starts with 6 valence electrons. If it uses 2n bonding, that means it has 2 lone pairs. So again, 4 pairs of electrons. 4 pairs of electrons go into a tetrahedron. But we only see 2 of them, because only 2 of the pairs have chlorides on them. So that molecule will be bent. And finally, trichloride. The boron starts with 3 electrons, forms 3 bonds. It's run out of electrons. So it has 3 pairs of electrons around it, so it is going to be trigonal planar. Problem number 4. What is the molecular weight of a gas if 0.289 grams of it occupies a 150 milliliter flask with a pressure of 0.953 atmospheres at 65 degrees Celsius? Well, molecular weight is mass divided by moles. Well, we have the mass, 0.289 grams, so we need a number of moles. And we're given a volume and a pressure and a temperature. And so for a gas, we can calculate the number of moles. So PV equals nRT, N equals PV divided by RT. 0.953 atmospheres times 0.150 liters, because it's got to be in liters. That means we have to use the R that includes liters and atmospheres, so 0.08206 liter atmospheres moles K, and 65 degrees would be 338 Kelvin. So we solve for N, so there's 5.154 times 10 to the minus third moles of gas. It weighs 0.289 grams, so it has a mass of 56.1 grams per mole. So on to problem 5, definitions. The Pauli exclusion principle says that an orbital can hold no more than 2 electrons and they must be paired. Standard temperature and pressure for gases. Pressure is 1 atmosphere, 760 torr. or 101.3 kilopascals. Standard temperature, 0 degrees Celsius, or 273 Kelvin. A double bond is two pairs of electrons shared between two atoms. Specific heat is the amount of energy needed to raise 1 gram of a pure substance by 1 degree Celsius. And finally, a molecular weight is the sum of the atomic weights of all the atoms that form a molecule. Problem 6. How much water must be added to 20 milliliters of 2 molar potassium sulfate to obtain a solution that is 1.25 molar potassium ions? We're adding water to a salt solution, so it's not a reaction, it's a dilution problem. And our equation for dilution problems is M1V1 equals M2V2. So the first thing we need is the concentration of potassium ions. Well, potassium sulfate dissolves to give 2 potassium ions. So if the solution is 2 molar potassium sulfate, it is 4 molar potassium ions. So 4 molar potassium ions times 0.0200 liters is the original concentration and volume. 1.25 molar potassium is what we want. We don't know what the final volume is. Set up our equation, solve for the final volume. The final volume would be 64 milliliters. But it didn't ask for the final volume, it asked for how much water should be added. So we have to subtract 20 from the 64 liters, so we would have to actually add 44 milliliters of solution to get our final solution. Problem 7. Give the complete Lewis dot structure for the following molecules or ions. Phosphorus tribromide, phosphorus ends up in the middle surrounded by bromines. The phosphorus brings 5 would like 8, the bromines bring 7 would like 8, there's 3 of them. So 32 minus 26 divided by 2 is 3 bonds. We need that many to hold it together. Each of the bromines has 3 lone pairs, the phosphorus has 1 lone pair. Chlorous acid. Oxygen brings 6 would like 8, there's 2 of them. Chlorine brings 7 would like 8, there's 1 of those. Hydrogen brings 1 would like 2. And the chlorine is going to get stuck in the middle. The hydrogen can't be in the middle, it only forms 1 bond, and the oxygens don't want to be in the middle. So they'll pick on the chlorine, and the hydrogen ends up somewhere on the end. So 26 minus 20 divided by 2, we need 3 bonds. That strings it together. The oxygen on the end has 1 bond, needs 3 lone pairs. The chlorine in the middle has 2 bonds, needs 2 lone pairs. The oxygen on the left has 2 bonds, needs 2 lone pairs. And the hydrogen on the end has just 1 bond, which is all it needs. Several people did expanded octets on the chlorine, which is okay in this case, but not necessary. If you used an expanded octet and actually did it right, then you got credit for it. And finally, nitrate. Nitrogen brings 5 would like 8. Oxygen brings 6 would like 8. There's 3 of them. It's an anion, so we have 1 extra electron. 32 minus 24 divided by 2 is 4 bonds, so we're going to get resonance structures. Each of the oxygens with a single bond needs 3 lone pairs. The oxygen with a double bond needs 1 lone pair. And the nitrogen with a double bond and 2 single bonds is its 8. Everybody's got a noble gas count. We've hung it all together. The electrons are right, but we have to indicate it's an anion. Give the ground state electron configuration for the following atoms. Chlorine, at 17, 1s2, 2s2, 2p6, that of course would be a neon inner shell. 3s2, 3p5 is chlorine's 17 electrons. Tin, The last noble gas is krypton. That's at 36. 37 starts the 5th row, so it's 5s. We're then into the D's. If it's a 5s, that's a 4D. It takes 10 to fill it. That gets us to 48, so we have to go into the P's. It's 5P, and it would take 2 to bring up tins 50. And last but not least, multiple choice. And that brings us to multiple choice. Everybody loves multiple choice. Indicate the letter or the answer that best completes or answers the following statements. A palladium 108 cation consists of, well, to be palladium, it's got to have 44 protons. To be isotope 108, it's also going to have 62 neutrons. And since it's a cation, it's got 2 less electrons, and so it have 44 electrons. Which of these atoms has the largest diameter? Our rule on the periodic table is down and left is bigger, up and right is smaller. So we have bromine, which is in the middle and all the way to the right. Germanium, which is in the middle and about 3/4 of the way to the right. Iron, which is right in the center. And potassium, which is all the way left and in the middle. And the one that is most left and down, of course, is the potassium. It would be the largest. What's the change in energy when 10 grams of water goes from 32 to 20 degrees Celsius? That's a specific heat problem. So the mass is 10 grams. The specific heat of water, 4.184 joules per gram degree C. The temperature change is minus 10 degrees Celsius. So 10 times 4.184 times 10 minus 10 is minus 4.18 joules. That's answer C. Which of the following photons carries the most energy? Well, energy is a function of frequency, so we simply have to look for one with the greatest frequency. We have 10 to the 7th, 10 to the 11th, 10 to the 18th, and 10 to the 14th. And so the gamma rays have the highest frequency. They would have the most energy. And so it's answer C. And finally, which one of these has the highest ionization energy? Our rule for ionization energy on the periodic table is down and left is lower, up and right is higher. And so we have magnesium, which is up and left. We have sulfur, which is up and right. We have barium, which is down and left. And we have bismuth, which is down and right. And so the one that is most to the right and up is the sulfur. And so the sulfur would have the highest ionization energy. And that concludes this school year's version of General Chemistry 2 of 2 with Dr. Petty. I hope you've learned a lot and that you can go on and enjoy the rest of your summer.